So let's begin with the crash course with C. Before we start, let's dive into like how why C and why are the architectures which are available. So the first one is the von Neumann architecture. So the von Neumann architecture is where both data and instructions are stored in a single memory space, allowing the processor to fetch and execute them sequentially. So it consists of three basic stuff. So CPU, memory, and IO interfaces, that is input and output. So the core concept is that the instructions and the data the programs manipulate are stored in the same memory location. So that's a single memory where both data and instructions are stored, and it allows sequential execution. The CPU fetches instruction from memory, decodes them, and executes them one after another. And the key components are the CPU, the brain of the computer responsible for fetching, decoding, and executing instructions. Memory stores both instructions and data, and input-output devices allowing the computer to interact with the outside world, that is the keyboard, mouse, etc., etc. So it is the design principle behind most of the general purpose computers which are available today. So that was one Neumann architecture. That is the main architecture which is like followed currently. And now let's dive into much more basic, like how memory is allocated in a C programming. So memory layout of a C program, it consists of like four segments. The code segment contains the program, that is the executable instructions. The data segments contain initialized and uninitialized variables. The stack segments, it is used to store the variables when we pass arguments to a method, and the heap segments used to store dynamically allocated variables. That is when we use mallocs to allocate those memories, it is usually stored in the heap segment. And whereas we just allocate just like we say int a equals to 2, that is usually stored in the stack segment. Let's look at this by code actually. Okay, are you able to hear me? Okay. So, okay, let's begin with some coding stuff. Let's first dive into how to write a C program. I'm assuming like you guys have a basic knowledge of the syntax, and so I'll just start with the hello world stuff. So, um, we need to include so there are headers in C programming, which is like libraries which you need to include. So they provide you with extra methods which you can use without directly declaring them. So the first one is standard input output library. So hash include stdio, and let's start printing hello world. So void main printf um, percentage s. So it means you are printing a string. That's why you need to write percentage s. If you want to print if you want to print a decimal or an integer, you can write percentage d, percentage I, or for a pointer, there is percentage p as well. So that's the formatting of it. And let be hello world, and yeah, slashing, and then yep, and let's try compiling it and see. And it provides us with a binary that is a dot out, and we can run this and see the output of it. And this will give hello world obviously. And now go into like how we can declare functions before we jump into the variable types, that is static and global variables. So let's start using some functions and see how we can declare functions and how we can manipulate the variables. So just make a add.c which takes in two numbers and returns the sum of it. So hash include stdio.h, and I'll declare a function called int add which takes in two parameters, int a and int b, and it just returns a plus b. And let's declare a main function to call this. So I'll declare it as void. You can declare it as an int as well. And So void means there is no return type. Int means it will return an integer. And there are other types like unsigned main and signed mains, which are used to return numbers as well. So let's do int x equals to 2, int y equals to 2, and I'll just call it, let's say, let's print the sum of it, and printf percentage d. That means the output format will be a decimal, decimal. So percentage d slash n add x comma y. So this will obviously print 5 because you're passing 2 into this and 3 into this, and all of these calls are in the stack, so you're not directly allocating any memory, so it is all going in the stack. So let's compile this, and if you try to run, it will print 5 obviously. Any questions still there? Is this recording? Yeah, it's recording. Okay. What is percentage d? So it's the output format, so that's why we use percentage d. If you want to, let's say, print any strings, you can use percent s decimal. Yes. For pointers there is percent p as well. Okay, yeah. Okay, let's dive into now static versus global variables. So there are many kinds of variables. Local variables are like, if you go into this program, so this is a local variable. That means its scope ends when you exit the main function. You can't access it outside the main function. Or let's say if I declare any variable called in c equals to 7, you can access the C inside this function scope only. If you try to access it, let's say here, it will give you a segmentation fault or some any errors saying the variable is not initialized. So that is a local variable, but let's dive into what's a global variable. So global variable is when you declare the variable outside all of the scopes of the function, that is in the top. So every function have can access the variable and read it and or modify it. So let's say in c equals to 8, and we can here update the c as well, it's c++, and we can print the c. Let's say here printf percentage t slash n c. So this will print the c. So we are, it is calling one time add, so the c will get updated once, and the predictor value should be 9 of the C. Let's check it. Yeah, it will be 9. So this is a global variable where you declare it outside all of the scopes, and every function has access to it and can read it or modify it. So that was a global variable. Okay, yeah. That's for character type, that's for sign integer. Yeah. Stream full screen on stage. Is it not full screen? You can. Is it full screen or not? Oh, okay. Now? Okay. Yeah. Okay. I got confused. So now static variables. Static variables are stored in the data segment and not in the stack, and they are active during the entire life of the program. So let's say you declare a static variable and inside a function, that variable will preserve its value even if till the expiration of the program. So that's what a static variable is. So let me show you by coding how a static variable looks like and what is a static variable actually. So let's make a static.c and hash include stdio um int And I'll take the addition example only, int a, int b, and it takes into integers and return a sum. So in between, we just check how many calls to the addition it took. So let's declare a static int calls equals to 0, and let's say int num equals to 0. This is another identifier to, let's say, it declares how many calls we have. This is the static and this is the normal int, and we just do calls plus plus and num plus plus. So every time the add function will be called, the calls will be increased by one and the nums will be increased by one. And let's say printf inside add called static variable value percentage d slash n, and I'll print the value of calls, and same I'll print the value of nums, and I'll print num here. And before returning, we just say return a plus b. So this will print the return the sum as well, and it will increment calls. That is how many times the function have been called. So I'm just taking two variables for calling, that is a num and a calls. And let's try with the main. And main, or make it a void. Um, printf percent d slash n, and 2 comma 3, and let's give it like three times. 4 comma 5 and 6 comma 7. So, what it should print. So, if we remember the definition, static variables preserve their value. So, every time this function get calls add, it should add the calls to one by one, but the num will get resetted. So, after this function call, the value of call should be 3, because calls is preserving its value after, even after it gets out of the scope, but num will get reinitialized to 0. Let's see how it gives. So as you can see, the static variable, it gives a value of 1, the first one, and the num value gives 1. So the first function call calls goes plus 1 and nums goes plus 1. And so yeah, and the value of the sum is 5. Second time, see the calls get 2 gets incremented to 2. That means the call is preserving its value throughout, as soon as it's getting out of the scope as well, because it's been stored, because it's a static variable. And the same goes with the num, and the num gets reinitialized again and again. You can see. Any doubts? So static makes local value persist. Yeah, basically, static persists the value even after it ends the scope. So static value variables will preserve their value until the full execution of the program. So static stuff isn't in the stack. Why just not make it global at that point? Um, that's actually a good question. Why not make it global at that point? Let me think. Um, It's okay. So one thing I can think is global variable can be accessed by all of the functions. Yeah. Yeah, static variable would be accessed by only that function. So if you make the static variable, let's say global, you can read it or write it by other functions as well. Whereas if it's a static variable inside a function, that means a limited access. Okay, there are many typings. So global variables are only accessible in the function in that function basically. So global variables is accessible by all of the functions, like every function can read it and write it. Whereas if you declare it inside the scope, that means it will be the access will be the functions or the function can only access it. It can't be accessed by other functions. Yeah. Okay. Any more questions or shall I move into the next topic? I think yeah. So static stuff isn't in the stack. So if you look at the nodes, so statics are stored in the data segment and not in the stack. That's what uh, that was on the, yeah, it's not in the heap. So that's what the nodes was, the OSSP nodes were. Okay. Okay, let's move into the next one. So pointers. So pointers is so what is a pointer? A pointer is basically um, a variable that stores the memory address of another pointer. And basically this is the example how you can access the memory location, and there's a concept of dereferencing the pointer. So to access the value of what the variable is inside that address, you dereference it. So let's look at this in a more coding style way. I'll make a pointer.c and let's start making a basic example of a pointer, and yeah, hash include int main or probably void main. Let's declare an integer variable x equals to 10, and let's try to access the address where the this variable is stored by using int star ptr. That's the declaration of a pointer to an int, and let's ptr equals to and x, percent x. So this way it stores the address of x in this ptr variable. So it stores the memory location of this x. So if I do print f value of x percentage d slash n x, printf address value of x percentage p. So that's the where I'm using a percentage p. That means it's a type of pointer, and x. So and x will give you the memory location of where the variable is being stored, and printf values stored in ptr percentage p slash n ptr, and now I can do printf value pointed to by ptr hd slash n and do star ptr. So let's see. This will give you the value of the x. This will give you the address value of the x. This will give you the value stored in ptr, and this will be the value pointed to the ptr. Let's try compiling and running it. So value pointed to the so the first value x is 10. That means it's correct. The address of x is something like this, and the PTR will point to X. So the PTR is pointing to the same memory location if you can see here and here. and the value which is stored by the pointer is 10. So when you star it, that means when you add a star before the printing it, so that means it's dereferencing the pointer, so you can access the variable inside it. Whereas if you do it like this, it will just give you the address of it. And let's try modifying the value of x with the help of the pointer. So I can do star ptr equals to 20. So if I do this, that means my x will now be 20. I can just print this again, and it should give me the x. Actually, let's do it as x, value of x. So the value of x is modified. So why do we need pointers? The first question will be this. So let's say if you have a very large data structure, custom data structure which you declared, you might not want to pass it again and again. So for that, you need to use pointers. So you just pass in the memory location of it, and your function can just access the data which you declared. So that's where it reduces your memory allocation also. Any questions? Um, when would you use a static variable versus a local variable? When you want your variable state to be persisted throughout your program, let's say you want to track the number of calls you made to a function, but so that you want to keep track. So for that, you might use static over there, because if you use, let's say, a normal or local variable, as soon as the function goes out of the scope, the value of that variable will be reinitialized, whereas the static variable will persist its value over the time. Can you use this instead of this, or in the stream just okay? That's just the stream. Zoom it on a bit. Okay, I'll zoom it. Okay, is it clear now? Let me know if it's clear. Yeah, that's better. Okay. So that was the whole gist of a pointers. Why do you need pointers and what are pointers? So basically, the basically you can say like pointers are more useful when you have, let's say, a much complex data structure, data type, or you don't want to pass it, and you just want to pass the memory location so that other function can also use it. Let's try another um, let's try a problem where we want to swap two variables with a pointer. So swap dot c. So we'll try to swap two variables, but with the help of pointer now. So hash include stdio. I'll do void swap int, and I'll take a pointer to an integer variable, two integer variables, in star a and in star b, and let's int temp equals to star a equals to star b, and star b equals to 10. So, and int main, and int x equals to 5 and y equals to 10. And let's do a print before before would be x equals to percent %d, y equals to percent %d slash n, and percent %y. So this will print the value which is before the swap, and now I'll call the swap function with and x and y. So I'm just passing the memory location of the variable. So currently it's int. So you can have, let's say, two arrays as well. So you don't want to pass the um, arrays value of the copy. So that's where you want to pass it by the memory location, so that the you just have the memory location and you can just manipulate with the memory location. So that's much more um how do I say, that's much more optimal. And now I'll print it after, so after the swap. And yeah, and if it's an int, then return 0. Let's try compiling it. So yeah, technically it swapped it, but so you pass in the, this is what is called pass by reference. So you pass the reference of the x. So that means you pass in the memory address of the x, and you just calculate it based on the address, and you just dereference it over here. Is it clear now, Till? Okay, I assume it's clear. So now, so that was pointers. There's a other concept which is called double pointers. So double pointers is a variable that stores the address of another pointer. So why it is used? Let's say you want to declare an array. So that's where a double pointer might be used and inside an array, because you want to allocate memories inside, because an array is a, let's say you declare an array of strings. So there there are two pointers. So your first pointer will be pointing to the whole of the array, and your second pointer will be like the inside all of the strings inside it. So let's look at it at a much more detail while programming. So I'll do double ptr.c and hash include stdio.h and int main. Let's say we want to declare an let's first see how double pointers works actually, because we said like it is a pointer to another pointer. So let's first declare an integer variable which is 42, and let's p be a pointer to x. So and x, and now let's point another pointer to p. So int star pp equals to and p. Now pp will point to p and p will point to x. So basically you can see pp is also pointing to x at that point. So let's try printf and x equals to percent %d slash n. This will be the value of x. Printf, and now let's print the value of pp. Sorry, p. I mean stop p and printf. And now let's print the value of star pp, star pp, percentage d slash n. Um, Pointer must be type of int and p star pp. Huh. So, why is it giving? Okay. Now let's try compile. Um, and star pp equals to, it should be this, and um does anyone know where's the error actually? Try star. Okay, it might be bugging because it's doing explanation, bro. Is gonna fix. Okay. Okay, let me try this actually. Um, nah, it doesn't fix it actually. Star star pp equals to and p, and no, it should be star star pp over here actually. But let's try compiling this actually. Unary int main percentage d x star p star star pp is, I think here it's failing because after this, so this is the problem I can see. If I do here and this compiles, so let's try having another pointer star star pb equals to and p, and okay, this is fine. Printf star star pp percentage d slash n star star pp. I don't know what happened, but it's now working. It's the same syntax. Cause did I? Nah, I don't think so. Okay, now if I do a dot out, so p x is also pointing to 42, star p is also 42, and star star p is also 42. And let's try printing out the address of each of them. So the address would be, if I just copy it here and paste it again. So the address of x will be void star, because if you want to print an address, you need a void pointer, and x be a void star p, and let's print the address of pp as well, be void star star pp. So this will be a dereference address of pp, which is the address of x. And print let's try compiling and see what the address is. Okay, gave some errors. Um, and x percentage. Oh, it's because these are pointers, not decimals. So you need to be careful with this. Now, if I compile it again, we find slash a dot out, and so this is the address of x. This is the address of p, and this is the address of pp. So each of them are p is pointing to x, and you can essentially say pp is also pointing to x at the end because it's a double pointer to the end. And yeah, that was a double pointer. And we will look how you can initialize an array with the use of a double pointer later. Is it clear till now? Do and p, okay. Do percentage p, okay. Yeah, I did that, okay. So the next are double pointers and then dynamic memory management. So dynamic memory management allows you to basically um, allocate the requested number of memory. Let's say if it's an int or a requested data type of your memory using structs, you can access that using mallocs, and those are essentially stored in the heap. So one of the main consequences of the dynamic memory management is if you don't free the memory which you allocate, it might result in memory leaks with if the allocated memory. So let's see how you can basically allocate the memory at first and then see what will how we can access and how you can free the memory. So let's make a file called malloc.c, and let me clear all these first. Hash include stdio and int main. Let's make an array, an integer array, and allocate the memory based on the size of the array. So int arr, int star arr, so it's a pointer to an array. And let's declare we want this five array of size 5. And let's try to allocate the array of size 5 using malloc. So arr equals to int star. So a malloc returns a pointer, um, and pointer to the first variable of the data type. So if the pointer is null, so that means memory allocation has been failed. Otherwise, it's been success. So you can do malloc n star size of. So you need to specify how much memory you want. So I want basically five. That's five integer size. So five star size of int. So this will give me the specified the amount of memory which I need. Now I need to check if the memory allocation has been successful or not. So I can do this by checking if ARR is double equals to null. If it's a null, that means the memory allocation has been failed, and I can do printf memory allocation failed, and I can just return one. And let's print the addresses of the memory which we allocated by looping through the array, and let's see what are the addresses that the program have given us. Addresses of the elements. uh, I'll just loop in through for in I equals to 0, I is less than n, and I plus plus, and I'll try to print all the addresses. So print f address of your percentage d, that'll be the address, and the p slash n will be I star. We want to take the address of this array. So for accessing the address, you do void star and array of I. So this will give us the now the addresses of each of the element which we uh, assigned using the malloc. So let's try compiling and see. So okay, I need stdlib as well. So this is the address of array zeroth element, first element, second element, third element, fourth element. So that's the five. And I can show you, you can essentially access the one more element also, but that's like much more of a memory leak, which is an issue. So currently n is 5, so that's 0 to 4. So if I try to access the sixth element, so it will be the next address basically. So array, you can see oops, sorry, go to five. Yeah, so if you see this, that's 048C04. So that means this is the fifth is the next consecutive element after the fourth element. Basically, you can read and write to this element as well, but this is not part of your allocated memory. So if you try to read and write, but in futures, it can be assigned to some other variable as well. And so at that point, when you try to access it, it will be giving a segmentation fault. So you need to be much more careful in these scenarios as well, where you dynamically allocate the memory and write to it. Let's try first to assign some values and print it. for int I equals to 0, I is less than n, and I plus plus. ARR of I equals to, I'll just assign the value and I'll just print it once. For int I equals to 0, I is less than n in I plus plus. I'll just, oops, printf percentage d slash t. So I'll print it with a tab and then ARR of I. So after printing, let's say our program comes to an end over here, but you need to free these memories as well because you assigned using mallocs. You need to free it, otherwise there will be these memory addresses will be remain in the heap. So I'll just free ARR and then return 0 basically. And let's compile. And so these are the memory addresses, and after assigning, I just, this is where I'm assigning the values, and this is where I'm printing the values after this. Any doubts till now? Uh, okay. So is there any questions? Okay, I assume no then. Okay. Thank you, thank you, thank you. Okay. Next thing. Okay, sorry, why did I open this? Mallocs and strings. So strings in C is much more like a character array. So C doesn't have a string, so you just basically have a character array, and at the end it's a null character. So I'll just show you how a string is created and how you can, what is the structure of a string in C. Strings. See, let's have hash include stdio, hash include stdlib, hash include string.h, and int main. And so let's declare a string. So I'll declare a pointer to a and a string. So that'll be a char star str. So this is essentially a pointer, and I'll allocate memory, let's say for 20 characters into this string. So str equals to char. So I need to convert the void pointer to a character pointer. Malloc 20 star size of cat. So I just randomly wanted to assign 20 size of 20 characters. So I'm assuming currently my character is of size 20. And let's check if memory allocation path, if str is double equal to null, I'll just copy this. Now I'll just copy strcpy. That means you copy the um, string into this memory. So you can't directly access by saying my like str equals to abc. It will give an error at the end. So if you wanted to change the contents of the string, you need to use strcpy and you pass in str, and that'll be, let's say, hello world, and let's print the value of the string. Printf string value is percentage s slash n str and return 0 gcc gcc strings.c. So the value of the string is hello world. Now I told you we can't do that. Let's try doing that and see what happens. str str equals to, let's say, Ayush. Yeah, see, it will assign integer without a cast, and if I try to run this program, it will be giving a null over there. So basically, it can lead to segmentation fault eventually if you are doing this down the program. So that's why the safe method is using strcpy. Um, Now let's dive into some string functionalities like the STL for strings. So basically, there are certain things which is called fgets and getchr. So let's try that. String fgets dot c. So I'll tell you what fgets is when I'm like doing the programming. Is there any doubt till now? Okay. Okay, okay. So hash include stdio hash include string, and let's do it in main. Let's take the size from the user currently. Let's int size equals to printf enter max length of a string. So, enter your name, enter the max length of a string. Okay, that's fine actually. You can do this, and scanf, I'll do percentage d and size. So scanf requires a memory address to the variable. So that's why I need to pass in the sizes address. So that's how scanf works. It needs a memory address. If you look at the declaration of the scanf as well, so um, it's a format, and then can I go to the declaration? Yeah, it requires a format, and then the you just provide it with the memory address. Let's try allocating the size of the string which the user specified. Char star name equals to char star malloc. Um, so we need to take so as I told you, strings have a null character at the end. So let's say if the user specified his name is, let's say, 5 letter words, but you need to allocate one more extra bit because you need to store the null character as well. So I'll just add size plus one star size of cap. So this will be the actually my character array, and I'll just check if name is double equal to null if the memory allocation failed. So if the memory allocation failed, then I'll just paste this over there. And get ch get char, it consumes the leftover line. So if your line has something like this, and so it won't read from this line, it will read from the next line eventually. So that's why I need to get chr over there, and I'll just printf. I'll ask the user to enter the name, enter your name, and it will be I'll just now have a fgets over here. Fgets will take in the name and the size. So name size plus one because we are taking the null character as well, and stdn. So why fgets? So the user can enter spaces also like this. So if you try to use other get char or some get line get cow or something like that, will just take in this bit, and then it will escape with the space over here, but fgets will take the whole of it. And then printf hello percent s slash n. name, and then return 0. Let's try running this gcc string fgets.c. So provider, okay, I need this as well. Lib. So enter the max length of a string. Let's say I'll do 6. Enter your name, Ayush. Hello, Ayush. So that's okay. That's basic. Let's print the visual representation of how the string is represented. Like you want to see how it is like the with the null character as well. So let's print for int I equals to 0, I is less than equal to size I plus plus. If name of I is double equal to slash 0, then I'll just printf slash slash 0, because slash 0 is an escape character, so I don't want to escape it, so I need to add another slash before it. Else printf percentage C name of I, and then I'll just format it using printf slash n, and now try running it. Enter the length of a string. So let's do 5. Enter your name, Ayush, and hello, Ayush. You can see it prints slash 0 here as well. So slash 0. It's not printing the slash n. Oh, it's opposite way. 5 Ayush. So it prints the whole of the representation, the visual representation of the string. So it stores AYUSH and the slash 0, which is at the 0th character. So this is the null character, which is terminating. Is there any doubt still now? Why don't we use or don't save it? Wait, what does getCat do here? Nothing, right? No, it basically consumes the whole line, so that's why I prefer to use getCat over there. Let's try strings with double pointer. I mentioned about double pointers and I told you I'll get there in the string. So let's try double pointers now. So strings with double ptr dot c. Let's include stdio hash include stdlib hash include string.h. Let's have a main function, and so double pointers will be like a pointer to a pointer. So let's have an array of names. So I'll kind of have an int n and ask the user to printf enter the number of names, and I can have scanf percent d, and I'll require the address of the variable, so it'll be ampersand n. So that'll be the memory address of the n. So now I'll try to assign the an array of that many number of strings. So let's say char star star name will be equal to char star star malloc n star size of char star. So that will be number of that'll be a memory allocation of an array, basically an array of strings. So if name is double equal to null, I'll have the check here. I'll print this, and then I'll looping through, and I will now assign the memory allocation for each of the string inside the array. Currently, it has been assigned for an array, and now I need to assign the memory for each of the string inside the array. So uh, for n I equals to 0, I is less than n I plus plus. Names of I, name of let's say it's name of I equals to char star malloc 20 star size of size of cat. So I'm assuming each name has a maximum length of 20. So this is the n star char of a pointer. So this is where I'm initializing how much array, how much length of the string each character will be. So it will be, and first we will declare an array of strings, and now I'm assigning the memory for each of the string. So I'm assuming each of the string is, let's say, a 20 character string, and now I'll check if name of I is double equal to null. Then I'll just print memory allocation failed and then return one. So this is allocated the memory. Now let's try get the names from the user and print it. Any doubts till now? The whole Ayush. What do you mean? Yes, basically, yeah. So I'll use a get chr. So that means that it moves into the next line. Basically, that's why we use get chr. So it consumes the current line and move the move it to the next line. So for int I equals to 0, I is less than n I plus plus. Oops. And I'll try assigning the names for each of the strings. So let's ask the user to print in the names. Printf enter name percentage d. Let's say ask the user enter the name first or second. I plus one. F gets name of I. Size will be a 20 and stdn, and name of I. So we need to remove the new line character. So that's one thing, because there might be somewhere like the user enters this and this. So we need to store the whole of it inside. So the space would be a delimiter over there. So it's basically we can do strcpn, if I'm not wrong, cspn, names of I, and slash n. Slash n equals to slash 0, name of I. So what it does, it scans through the whole string from left to right. It stops as soon as finds any character from the second string. So that's what strcspn does. It scans through the whole of the string from left to right, and it stops as soon as it's find any of the characters from the second string. So now I need to print the names. Let's print the names. Printf print names for n I equals to 0, I is less than n I plus plus. Printf percentage s slash n name of I. So this I'll print the each of the name inside the array. So this will print the each of the name inside the array. But after, let's say, I'm now ending the program, so I need to free the memory which I allocated. So for so it's a double pointer, so I allocated it's a 2D array. So I need to free each of the strings individually. So I can go around the whole of the array for int I equals to 0, I is less than n, I plus plus, and I'll free each of them. So let's say free name of I. So after this, I'm freeing the whole of the memory, and then I'm freeing each of the string currently inside the array, and now I need to free the whole array. So I'll do free name. So this free is exactly each of the strings, and this free the whole array, and then I'll return 0. Let's try compiling and running it. Oops, not this. GCC strings double pointer. Let's say I want two names. Let the first name be John and the second name be Bob. So the print names will be John and Bob, and after this it frees the name. Is it clear till now? Basically, yeah. Okay. Now this was the strings part. Let's move into the next one. So pass by value and pass by reference. That's one thing. Before that, let's start. Let's do. Okay, no, the structs are the first. Structs. So what is a struct? So you want a composite data type for your program. Let's say you have a student, which student struct which has a name, age, grade, and together, and you can just make a composite data type using structs. So that's why structs are much more bare. So basically, C doesn't have object-oriented programming, so you can achieve a similar kind of thing using structs, but still you can't have those accessing functions like using public and private stuff. So struct is basically used for grouping multiple data types into a single data type. So let's see how you can declare a struct and how you can access it. Um, struct.c, struct.c. Um, let's include hash and include stdio. Um, let's declare a struct. I'll take the example which was in the slide, a student struct which is having a name, age, and a grade. Student, it will have a char name of size 20, int age, and float grade. Now, let's say I want to declare a main function, and I want to let the user enter, or let me insert some a student data structure, and let's say print it. I can create instance of it or using struct student student one, and let's assign the values to the struct field. So sn printf. So I'll take a student one dot name, comma, size of student one dot name, and let's assign the name as John Doe, and student one dot age is, let's say, 20, and student one dot grade is, let's say, 88.3. So let's print the student one and then see what it contains. How you can access the each of those variables inside a struct. So printf name would be percent s slash n student one dot name. Printf age would be percent d slash n student one dot age, and printf grade would be percent. Let's have it to two floating points, so I can have it like 2f slash n, so it prints up till 2f, two significant figures, and then student one dot grade, and then I can just return 0 from here. So this will initialize the whole of the student structure using this, and then I'll print it. So I can do gcc struct um, a dot out. So that's initialize. And so you might think having the struct written here and you're writing a struct, so you can get rid of it by using just having a type def in front of it. Type def student, let be student student underscore t. So that's a student type, and now you can initialize this without having a struct written every time in front of it. So you can just be like declare it like this. So this is also one of the easier way to like get rid of structs every time, like while you initialize it. Is it clear till now? I'll assume yes. Okay. So structs are there now. Let's move on to pass by value and pass by reference functions. So the whole point of having pointers is you can pass by reference. So pass by reference is like when you want to pass the memory address of the, let's say you have an array or a struct, and it can be like a lot of big in size, and so you don't want to pass it again and again and by passing a copy of it, so you just pass in the memory address and it manipulates it. Even in Java, the classes, when you declare, let's say when you declare a list of integer equals to new array list, and you pass it to another function, mm, let's say a foo, and it takes a list of integer, it is getting passed by reference only in Java also. So Java does it all under the hood, but in C you need to actually do it by yourself. So pass by value, it passes the actual copy parameter to the function, and any changes you make in the function doesn't reflect the original value. Whereas in pass by reference, you pass in the memory address and you directly modify the memory address. So any change you make in the pass by reference, it is actually visible when you try to access it. So let's try and see how you can do it. Let's try the pass by value. Pass by value.c. Also, if you, let's say, do any kind of uh, if you are doing lead code or something like that, one you have seen, like if you try to pass in, let's say, a vector or a list by a, if you pass a copy of it, it will sometimes give you memory limit exceeded because it passes in the entire copy of the vector or the array again and again inside the function. So that's one thing also, whereas passing a memory reference is much more optimal. So hash include stdio, hash include string.h. Let's declare a struct type def struct student. It will be um, let's say it has a char name of 50. Let's say the name is of size 50 and age, and float grades, and let be student type. I'll print the student, let's say void print student, and it will take a student student t of s, let's say, and I'll try to print the student which is passed into here. So I'll printf original name. Original name will be percentage s slash n, s dot name, and let's try to modify the name once and see how does it. I told you, like, you if you change the copy of the original value, it doesn't reflect in the original value. Let's try to change the name. So strcpy s dot name to, let's say, I'll pass Ayush, um printf modified name percent s slash n, s dot name. It should modify the name and then printf um, age percent d slash n, s dot age, and let's just limit it to just age and name only. And main, let's declare a student, student type s1 equals to, let's make it a, let's have it Bob, and age of 22. So student one has Bob and age of 22, and I'll just print students, and I'll print S1. So this should print the original name as Bob, and the second name is Ayush, and 22 here. But let's try to print it over here as well, because you are changing the Bob, the name over here. Let's try to check if it actually prints or not. So I'll just copy this. Name is s1 dot name and s1 dot age, and yeah, return 0. So gcc pass by value dot c, and so see, I passed in the student name and printed it. Here it should print Bob, then modified it to Ayush, and then printed the age. So that's the first function call which is going in here. Now I try to print it again after printing the students. So I try to print it. It's still Bob, so it's not changing it. So the you can see it's passing a copy of it, neither like not a memory address. So if you want to change it, so you can just have it pass a pointer to the memory address of the struct, and you'll be able to change it. So let's try to pass it by reference and see. Pass by reference, you just need to have a pointer to here. And now, as soon as you add a pointer, so you can do like this. Um, s dot name would be, now I'll change it to Ayush, and modified would be s dot name and s dot age, and print student. So I'll need to pass in the memory address of the reference of the student S1. So this is, I passed it, and now I'm printing it again. So let's try to compile it. Now you can see the original name was Bob. I modified it. I changed the age. Now if I'm printing it here, it prints Ayush and the age of 22. So this is how you can. That's the difference between pass by value and pass by reference. Is everything clear till now? So Java passes classes by reference by primitive value. It has capital letters. Yeah, basically. Um, so dereference the variable within a struct. Yeah. So yeah, basically. Yeah, Java passes the primitives. Yeah, that's the same type. So this is much more convenient. Um, And in Java, the primitives are passed by value, but the one where you declare a class. Even let's say if you do it like this, integer x equals to new integer, something like this, it will be passed by reference as well. So yeah, because here you're creating a new class of it. But I might be wrong over this, but I have seen somewhere I'm doing this, but it's passed that by reference. So now file handling, and yeah, so file handling is like when there are many functions in file handling, like fopen opens a file, fclose closes a file, and these are all the list of the file handling functions which you will need basically. And these are the modes, which is R for reading, W is for writing. If the file doesn't exist, it creates a new file, and A is for appending. Appending means it adds to the end of the file, and if the file is not there, it creates a new file. And RB and WB means it opens it in binary mode, that is read byte and write byte. So let's try and do some file handling code. So let's just do a basic writing to a file. Write to file dot c. Um, Hash include stdio in main, and let's create a file pointer, a pointer to a file. File equals to um, fopen um, example dot txt. And see, I don't have an example dot txt here, and now I want to open it in write mode, so it should create the file over there. And if if it fails to create the file, that means I'll just print, let's say, printf file equals to null. Printf error opening the file, and return one. And let's open the file and just write some lines into it. So f printf to the file, and let's write hello, uh, and f printf. So it will print, and let's print it in a new line. So after this, have a slash n, and file. mm, this is another line, slash n. Now it should write in the file. After writing in the file, you should obviously close the file. So f close, there's a function, and then it closes the file. And after printf, let's print in a statement if it executes here, success, and then return 0. Gcc write to file.c dot a dot segmentation fault. So nice. Okay, where did it cause the segmentation fault? Example.txt fclose file, example.txt in a write mode, file equals to null, error opening the file. It opened the file. Let's print f here, printf control here. um File, this is another line, fclose file. So this is you write to a file. I guess segmentation fault. Let's see, f printf file return 0. So Okay, so after this, probably it's having a segmentation fault here, I guess. Oh, it's because I'm comparing it right wrong. It should be double equal to, not single equal to. So control here and success. So let's see the example.txt, and this is there. Hello, how are you? And this is another line. So yeah, now this was the writing to a file. Now we just now try to read from this file. So if you want to read from this file, I'll just remove these here before closing it. After closing it, let's open this file again. File star file equals to f open, um, example dot txt in a read mode. Oh, file star r file probably, because and if our file is double equal to null, then I'll just write this error over here. And let's try reading it line by line. Let's declare a char line of 100 character line, long line, and then while f gets, so if it will get line by line and line comma size of line, and in the file I need to get it, so that'll be 5. So and I'll print the line by line. So printf, it's a string, so percentage s line, and then after this f close r file. So they should essentially write it to the file and then read it again. So let's delete this example.txt for now, and let's try seeing it. Dot slash a dot dot. So it writes it first and then it prints all of it. So it prints hello, how are you? And this is another line from from the example.txt here. So this is how you can read from the file and write from the file. And now let's move on to the last concept, which is function pointers. So a function pointer is a function. Function pointers in C are a point to a function, so it allows you to call dynamically call a function dynamically through its address, more useful for callbacks and dynamic dispatches. If you have done more like JavaScripts or TypeScript, so you know you can pass in a function as an argument. So function pointer helps you to achieve a similar kind of result using in that. So you can pass in a pointer to a function. So let's see how you can declare a basic function pointer. Till now, is there any doubt? It's fine. Assume it's fine. Okay, all good. Okay, all good then. So, function pointer basic. So, function pointer, let's say we have hash include stdio.h. Let's have a function called void greet, and you can have printf hello from greet function. And let's have a main function now in main, and let's have a pointer to that function. So you can declare the pointer to that function using void start function atr. That's the That's the declaration of it, and then you can point that function pointer to the greet function. So it'll be like function ptr equals to greet. Now you can call in the function pointer and it will be printing the greet function. So you can do f u function pointer and then dot a dot. So hello from greet function. So that's how you declare the basic. That's the basic syntax of a function pointer. You declare the function pointer first, then you initialize with which function do you want it to point to. So let's see how you can have a function pointer with parameters. So let's change this function to add, and it takes an int a and int b, and it returns a type of int, and it returns a plus b for now. And after this, so as your data type of the function change, so you need to update it here as well. So from void it'll be now an int, and now it'll be pointing to add, and now I can access this as int res equals to function pointer of 5 comma 3. So that'll be adding the two variables over here, and then I can just printf res is percentage d slash n and press and return 0. So this in this way you can this function pointer is pointing to this add function after this declaration, and now it should be here. So let's try and compiling it and running it. So res is 8, so you can see here. So it gets 5 and 3 and it prints a result of here. Okay, so that's basically a function pointer. Now you can pass in a function, as I told you about callback. So how you can assign a callback to a function pointer. Let's make another program which is passing uh, function ptr to a function dot c. So in this, we'll try to achieve something which is called a callback. Hash include stdio. Let's have an integer of multiply. It takes in two parameters, int a, int b, and it return a star b. And let's have a function called void perform operation, which takes in an int x int y and a function pointer which is pointing to an operation in star op, and it takes in two parameters int comma int. That's the basic declaration of it, and it just calls in the printf result is percentage d slash n. It calls in the op of xy, so that's the operation which is passed, and you're just calling it. And let's try calling it from the main. Int main perform operation, let's say 4 comma 5 comma multiply, and return of 0. So let's try compiling it first. GCC. So result is 24, 5 is 20, and it goes through here, it calls in the function, it calls in the multiply. So it is essentially called like a callback, which is over there. Yeah. There is also, if you are like more from the JavaScript world, there's also something called a callback hell as well, which which you can look in like using the docs, how you can get rid of it. And now array. Now let's have it in such a way we return an array of function pointers. So that'll be array of function ptrs.c. So in this, we'll try to have an array of function pointers and we will try to do the operation in an array. So hash include stdio.h and let's have an int add which takes in int a comma int b and it returns a plus b and int sub it takes in two parameters int a comma int b and it returns a minus b. Now to access it, it can have a main function and you can have int star operations. Let's say we have two operations inside an array. So that would be an int comma int and it would be having the operations are add comma subtract. So this is an array of function pointers now. And you can have printf addition is percentage d slash n and operations of 0. That means I want to add it and along with the parameters, let's say 10 comma 5. And same goes with the subtraction. Sub is operations of 1. And let's try to compile it. GCC array of function pointers. So subtraction is 5 and addition is 5. Subtraction is 5 and addition is 15. So that's what an array of function pointers does. So you can have an array of, let's say, of different kind of function and you can have perform different operations with that. And yeah, that's it, I guess, for this crash course. Any doubts? What does star operations do? So star operation where? Oh, star operation is a function pointer which takes in two int variables and it is an array and the first element of the array is an add function, the second element of the array is a subtraction function. So it is basically an array of pointers. So it's a function pointer of two. So it's an array of function pointer basically. Array of function pointers, yeah. Is there any other doubt? Can you go back to the code? Okay. Yeah, there you go. Actually, I'll upload the code to my GitHub, so don't worry if you missed out. Cool. Okay. Anything else, guys? So I assume then, all good then? No issues, man. No issues. Bro. Okay. All right. Thank you. Okay. Welcome, welcome, guys. Then I'll end the session here, and I'll upload the code to my GitHub, and I'll add it over there then. All right, guys. Safe.